Let's do some more stacking and unstacking. And first we'll create this pdata1 data frame. It's a 2 by 3, and as we've seen before, it will convert it into a series by moving those column names down into a hierarchical index. And so those column names have become hierarchical index level 1. And we've already experienced that unstacking is the reverse, or the reciprocal of stacking. So if we just take this new variable result that we just created and we unstack it, we should get back to the original pdata1 that we had. And that works expectedly when we have a matching data frame where all the values align. But what about if we create a data frame where the values do not align? Here we have two series. This series has 4 values and this has 3, and they only match on C and D. Here C and D both match, but A and B don't match, and E does not match either. So you might be able to predict that when we unstack this and it becomes a data frame, it's going to have 3 empties. It's going to have empties in the A and B and in the E where we didn't have any matching values. So we've unstacked that. Now just as before, stack is going to reverse that. So it'll turn this back into a series again, but it'll also filter out the empties when it does it. So here we've gotten back to the exact original, and it has removed those empties from the list of values. But we can actually tell pandas to keep those empties, and we do that by setting drop NA equal to false. And if we run this, then you can see we have all those empties there. And of course, this series can be inspected. We can just call the 1 index there, or we can inspect the 2 index. We can actually drill into the next level and get the C index of the second index, which is a 4. Now, pivoting in some ways is quite similar to stacking and unstacking, only we have more control. Here's this series that we created above. It has a hierarchy, and we're going to create a data frame out of 2 copies of this series. In the second copy of this series, we're going to actually add 5 to each of the values so that we can differentiate them, and we're going to give it some column names left and right. What will happen if we unstack this data frame? Well, it's taken the 1 level index and it's converted those into column names, so that now rather than having a hierarchical row index, we now have a hierarchical column index. And we can actually control a little bit which columns get converted. If we put a 0 here, rather than getting 1, 2, and 3 as column labels, we get our states as column labels instead. But of course, as we discussed earlier, pandas will default to the 1 index if we leave that undefined. Now, just as we saw before, stacking and unstacking are the reciprocal of each other. So if I delete this out of here and run an unstack, we'll get back to our original data frame. But when we have hierarchical indexes, we can make choices on unstacking just as we could make choices on stacking. So what happens if we tell this to unstack side instead of number? Then the numbers remain in the columns, and the side index becomes the level 1 hierarchical index for our rows.